Hello guys, in this video I'll be going over how to add, subtract, multiply and divide complex numbers, as well as some other ideas that will be important for this section. So first we've got addition, and it's quite simple. When adding two complex numbers you just have to add the real parts together and then add the imaginary parts together. So in this example here I'm doing z add w, where z is 3 add 4i and w is 7 minus 3i. So I'm just going to expand the brackets out. So we've got 3 add 4i, add 7 minus 3i. Then I'll add the real parts together. 3 add 7 is 10. Then I'll add the imaginary parts together. 4i minus 3i is going to be I. So z add w is just 10 add I. Subtraction is very similar to addition. You'll just want to subtract the real parts and then subtract the imaginary parts. So in this example I'm finding z minus w, where z is minus 4 add I and w is 9 minus 8i. I'll just expand the brackets out so we get minus 4 add I, minus 9 add 8i. And then for the real parts we've just got minus 4 minus 9, which is minus 13. And then for the imaginary parts, I add 8i is 9i, giving z minus w to be minus 13 add 9i. On to multiplication. All you have to do to multiply two complex numbers is multiply out the brackets in the usual way and then simplify, making sure you remember that I squared is equal to minus 1. So in this example I'm doing z times w, where z is 5 add 4i and w is 3 add 2i. So I'm going to expand out as normal. So we've got 5 times 3, add 5 times 2i, add 4i times 3, add 4i times 2i. And that will be equal to minus 8 because I squared is equal to minus 1. So then we've just got to add it all together and we end up with 7 add 22i. Now this question here is a bit trickier. It's more like the sort of question you'd actually get in an AS or A-level exam, and to solve it you'll need to know about something called the equality of complex numbers. And that is, for two complex numbers to be equal, the real parts must be equal and the imaginary parts must be equal. This might sound kind of obvious, but it's really useful because it means that when we've got an equation with a complex number on both sides, which is often the case in this section, we can equate the real parts and also equate the imaginary parts. And you'll see what I mean by that in a minute. So in the question here, I need to find real numbers p and q that will satisfy the equation. What I'm going to do first is expand the brackets by multiplying out, and then I'm going to group the real numbers together and also group the imaginary numbers together. So now I've got an equation with a complex number on both sides, I can use the equality of complex numbers to equate the real and the imaginary parts. Equating the real parts gives me the equation 3p minus 5q equals to 1, and equating the imaginary parts gives me the equation 5p add 3q equal to 0, because you can think of 1 as 1 add 0i. So now I've got two equations and two unknowns. I can solve these simultaneously to find out that q is equal to minus 5 over 34 and p is 3 over 34. Before I move on to the slightly trickier task of division, you'll need to know what is meant by the term complex conjugate. Basically, every complex number has a complex conjugate, and the complex conjugate of a complex number has the same real part and the negative imaginary part. So for example, the complex conjugate of 3 add 7i is 3 minus 7i, and this is denoted by w star. So finally, to divide two complex numbers and get the answer in the form x and yi, you'll need to multiply the numerator and the denominator by the conjugate of the denominator. So in this example here, I'm going to multiply top and bottom by the conjugate of 6 minus 2i, which is 6 add 2i. On the top, I'll multiply out as usual, remembering that I squared is equal to minus 1, but on the bottom I'm going to use the difference of two squares. You could just multiply out as usual, but because the multiplication is of the form a add b times a minus b, with a as 6 and b as 2i, it's easier just to say that this is equal to a squared minus b squared, and this will always be the case when multiplying a complex number by its conjugate. After some simplification, I finally get that 7 add 5i divided by 6 minus 2i is equal to 4 over 5 add 11 over 10i. And that will be it for this video. I really hope you enjoyed it. Next video will be on solving quadratics, cubics and quartics using complex numbers, so do check that one out. Bye.